The final topic in our preview is probably not going to be the final topic of the course. If we take a look at this particular outcome, graph and analyze reciprocal functions limited to the reciprocal of linear and quadratic functions, we are going to be looking at how to graph things like 1 over ax plus b and 1 over ax squared plus bx plus c. So the reciprocal functions more than the rational functions. So this seems a little out of place in this sequence to me. It is a more natural connection to the work in quadratics and other rational functions above. That's several outcomes above, rather than those infinite arithmetic and geometric sequences that we just talked about in parts 9 and 10. So this will be another case where the order that these are taught is not going to match the order that they are listed in the curriculum. But everything will be covered. So this is the last thing that we're going to be looking at. And the key here is to remember what happens when you reciprocate a number. So if this is ax squared plus bx plus c, then the reciprocal function is going to have what we call asymptotes. These are lines that you can never cross coming up at these points. So where the original function becomes 0, the reciprocal function goes to infinity. They're going to be equal at 1. You're going to get close to the axis here, equal again at 1, and then come down towards a negative infinity, as this is a negative number getting closer and closer to 0. On the other side, we are going to have more so-called asymptotic behavior as we come here. So an asymptote, asymptote, is a line that your function will never cross, but it can get very, very close. If you can pick a number as small as you want. Say, when is it within 1 over 1 million units of that asymptote? You will be able to find a point where it gets that close, but they will never meet. So this has a horizontal asymptote at 0. Because as this graph goes to infinity, the reciprocal will get smaller and smaller and smaller. But because you'll never actually reach infinity for any finite x, so we can graph it on a finite page, the y is never going to come all the way down to 0. It can get as close as we want it to, but it'll never actually hit it. So these are the key ideas that we're going to be looking at. So every time our graph crosses the x-axis, we're going to have a vertical asymptote. And because the polynomials always go to plus or minus infinity at the ends, we're always going to have some kind of horizontal asymptote. So this is something that we will deal with in much more detail next year.